Okay, so hello everyone. Welcome to the meeting of the 6LOW Working Group. Please make sure that you are in the right room. My name is Carlos Gomez. The other chair is Shweta Bandari. She's attending remotely. And our responsible AD is Eric Winker. And we still have to find some minute taker for today. Is there anyone who would like to volunteer? So recall that we don't need the minutes to contain everything that's being said. We need mostly the main action points, main decisions. Yeah. Okay, thank you, Luigi and Eric. So other than that, recall that for taking minutes, as usual, we are using HedgeDoc. So everyone feel free to join and contribute to the collaborative process of taking minutes. You can find the link at the end of the slide and also on the chat. So similarly to the last few IETF meetings, there are also some tips for this one. For in-person participants, make sure that you sign into the session by using Meetecho. You may use, for instance, the on-site tool, which you can find from the data tracker agenda. And recall that you need to use Meetecho to join the queue, because there's a single unified queue handle from Meetecho, and also blue sheets are automatically generated from Meetecho. So everyone in the room, please make sure that you have actually joined the session. And for remote participants, just keep your audio and video off unless you are presenting something. This is the Notewell. This point of the week, probably you may have seen it several times already. Anyway, this is an important reminder of IETF policies, which are in effect on several important topics such as patents or code of conduct. So please make sure that you have read it. And this is the agenda proposed for today. So the first presentation is the usual chair's introduction, which is currently in progress. This will be followed by a presentation on IPv6 neighbor discovery prefix registration. The slides have been prepared by Pascal, who's the author of the draft, but Luigi will be channeling Pascal, so thanks a lot to both. And after that, Luigi will present the set of two documents, first one being path-aware semantic addressing for LLNs. So this is the main PASA draft, and the related draft generic address assignment option GAO for 6LoWPAN-ND. After that, I will present the status of the transmission of IPv6 packets, SHIP compressed packets over 15.4 networks. And finally, Youngwan will present the transmission of IPv6 packets over short-range optical wireless communication. This leads to a total of 70 minutes of allocated time in the agenda out of 90 minutes for the session. So we have some margin if something needs further discussion. Is there maybe any comment on the agenda? Okay, so if there is no comment, then this is the status of the working group. Recall that after Dublin 6LoW was rechartered, this was a rather minor update, basically intending to reflect the current state of the related working groups and developments today compared with the original charter of the working group, which was from 2013. And also we have milestones. There is one associated milestone to each current working group document. And well, as you will see, the couple of earlier milestones that we have are for two documents, and we believe that we are quite aligned. We are complying more or less with the dates expected for the milestones, as you will see right next. And this is the report on the working group documents status. So first of all, Since the last IETF, we have a new RFC, which is RFC 9685 on listener subscription for IPv6 neighbor discovery multicast and anycast addresses. Congratulations to the authors and many thanks to everyone who has contributed in the process. And by the way, actually a couple of days ago, Adnan sent a message on the mailing list mentioning that, and it appears that he is right, that there is a new P field defined in this new RFC, which appears to overlap with an existing C flag in a previous RFC, which is 8928. And yeah, we might need to see how to proceed with that. Adnan has actually provided an errata for this latter RFC, which was editorial, but perhaps he should do the same for this technical errata. So I see some nodding. So yeah, we will. Yeah, Eric.
Eric Vink has responsibility here. Obviously, if there is an overlap of overlapping semantics and different semantics on the flag, it's way more than an errata. Honestly, I will need to check how to proceed on this one. Hopefully, they are not yet implementation and deployment, so we can still fix it.
Okay, so Adnan should submit the errata report, right? Yeah, okay. Okay, so then we have 5 working group documents. The first 2 are quite advanced in the process. The first is path-aware semantic addressing, PASA, for LLMs. And the second one is IPv6 ND prefix registration. So for these 2 documents, well, they passed working group last call. The Shepherd write-up is uploaded. And later today, we'll be able to see which are the next steps for these documents. Anyway, they will be both presented and have been updated since the last IETF. And the remaining 3 drafts have also been updated since the last meeting and will be presented today. So the first is the transmission of SHIC compress packets over 15.4 networks at revision 09. Next is transmission of IPv6 packets over short-range optical wireless communications at version 03, and generic address assignment option GAO for 6LoWPAN-ND, also at version 03. So is there maybe any question, any comment? Okay, so if there is no comments, then we can proceed to the next presentation, which will be given by Luigi on IPv6 neighbor discovery prefix registration.
You are stuck with me for a while.
I'm not sure this one will work. Okay. Slides control. Let's see. Yes.
Yes.
Okay. Works. Cool.
Okay. So as Carlos said, I'm here on behalf of Pascal to give a brief update about the prefix registration document. Okay. Just as a context, this is one of a set of documents that go in the 6LoWPAN-ND starting from 6775. There have been various extensions and new features that have been added. And the last one of this document is the fact that a node can register a whole prefix to a neighbor router in the context of 6LoWPAN. Okay. The main changes are very few. The technical content is stable since the last meeting, has not changed. there has been text added to clarify the motivation. I will go over that in the next 2 slides. And just as I recall, this document already passed the working group last call, okay? But because of the modification, we give a brief update here today. So the first updates is about energy saving. The fact that in order to try to save energy in the context of LLMs, there is more complexity that we put on the router, okay, in order to simplify the host implementation, okay, and avoid to expand the control traffic to each and every node, okay, and remain to allow restful operation in order to allow the fact that there are transient disconnections, okay. LLN is for low power lossy networks, so we have transient disconnection, which means that we need to be to have a stateful solution. So in order to have a proactive knowledge of the routers that are available at any point of time, the communication between the host and the router are unicast, okay. This is because is also to avoid asynchronous broadcasts that are very, very expensive in terms of energy efficiency in this context, okay. Second main change, clarification about what this specification extends, okay, and the fact that this document allows to register a prefix without the need to know what is the routing protocol that afterwards will announce this prefix. And on the other side, the routing protocol does not need to know how this prefix has been registered into the router, okay? Again, this also allowed to reduce energy consumption. A few other points is that when advertising the prefix has been a design choice not to use array messages, okay? This is because if the host does that, it will appear as a router, okay, to neighboring nodes. And also, there was a design choice to avoid broadcast. This has been already said. And also to extend the ERO messages as opposed to the route information option, okay? Because the route information option is explicitly not intended to be used to routing, is lacking the related control about the RBIT. And to me, more importantly, is the fact that the route information option cannot be trusted blindly, okay, because he is lacking the equivalent of the rover field that we use in the ERO, okay. And that's all. Quick update on from the last IETF.
Okay, thank you, Luigi. So, yeah, as mentioned before, this document has passed working group last call. The Shepherd write-up is ready. It's uploaded. And so, yeah, we are wondering, okay, the next step might be maybe pressing the button for submission to the ISG. So, Eric, would you have any?
So Eric Vink is the next guy in the queue for processing this document. Yes, ship it. Now, the telechat dates are quite busy, so don't expect any ISG approval before end of May, early June at the latest, right? You got big queue right now. But else, yeah, do it.
Okay, thank you.
Good.
Okay, so next we can proceed to the next presentation, which will be first on PASA and then on the related document GAO. So again, it's Luigi presenting.
Yep, I'm presenting again. So we okay, I have the powers again. We had a couple of the revisions that have been submitted from the last IETF. There was one quick one that has been submitted in order to be in line with the GAO simplified format. I will go over the simplification in the next presentation, but we had to align to the documents. Okay. Carlos did an excellent Sheffield's review, and Brian Carpenter also gave a few comments on the mailing list. So thanks to both, and we submitted a new revision. And then, we were until revision 10. We were more than 5 authors on the first page. So some discussion. We are now in line with the ISG guidelines. We are only 5 authors and 2 contributors. And I mean, I will not go over the revision 11 because it's just this neat. So what we did, we updated the examples in order to be in line with the GAO document, but technically we didn't change anything technically in the document. Okay, just to use the simplified format. There was an interesting point about topology changes. This was brought out by Brian. So we decided to add some text. So there was in the previous document there was just the reliability considerations. So this time we created a section deployment considerations, and where we also fit the reliability text. Okay, but we also added some text about topology changes. As you know, PASA creates a tree. Okay, so when there are hosts that join or leave the network, this is easy to be handled. Okay, because they come and go. They are just leaves of the tree, so it's very easy to handle. If there is a router that is joining or leaving, because of the deployment context that we have in PASA, this is a little bit more trickier. Is a structural change which may require a renumbering of a branch, okay, or depends really on the topology, several branches or the whole network. But usually when you do that, you know it in advance. You can plan a little bit things in order to avoid the renumbering, disruption, sorry, to deal with the renumbering. And that's it. I mean, in a certain way, you can use the solution for the reliability when you do the renumbering, okay? And as I said, Carlos did an outstanding job in the review, so we had the opportunity to refine and clarify the document in various parts. We don't need to go into the details. If you look at the diff, you will see that almost all the figures changed, but not in what they express in the way we design the figures. It's just because in this way, in the BTF format of the document, we have SVG pictures like you see here that are much more readable when we don't use ASCII art. Yeah, that's it on this document. So the question is whether Eric wants to have yet another document in his queue.
I don't know.
Okay. Any question or comment from the room?
Yeah, so perhaps one detail is about the process. This document has a normative reference to the GAO draft, and the GAO draft will be presented right next. So I guess that one option would be to submit to the ISG right now, or the other one would be submitting both at the same time. I don't know what might be better.
As you prefer, Eric. Good point.
So, Carlos, this is indeed a good point. When there are two documents, basically what you call in a cluster, I will submit both of them at the same time as the ISG, right? So either it's all in my own queue or in the working group queue. Now, a small favor, because AD evaluated my matrix, my KPI, right, is how long a document sit in my publication queue, right? You've seen the slide yesterday in the plenary. So keep it in the working group. But if it's annoying for you, it's just a small favor I am asking.
No favor. Makes sense. We keep it here and then
look,
we will push it.
Ex-previous AD who is laughing now.
We can push the two documents at the same time to you later on. Anyway, this document has to wait for the other one. So.
And most of them will get RFC numbers next to each other.
True.
Okay, Sam, sounds very good. Okay, so then if there is no other comments, then we can proceed to the next. So this will be the presentation on the related document, the generic address assignment option for 6LoWPAN neighbor discovery.
Yeah. Here as well, we had a few revisions. We submitted the first one really to simplify the format. The second one to clarify the use case, so when to use this option. And actually, we realized afterward that we forget to update the IANA section and what was suggested as a bit usage. So we submitted on Sunday a third revision of fixing this part. Okay, so the simplified format, just to remember, the option, really we build it at the beginning, mimic a little bit the ERO message, so the option. We put the same basically flags in some parts, but coming back again and thinking, do we use really these flags? The answer is no. And even the AIF, which is the address allocation function, we don't need 8 bits. I mean, we shrink it to 4 bits. We reserve all the flags that we did not use. Okay, so there are a few reserved bits that, in case, can be used in the future if we really need to extend anything of this message. Okay. And we reworked the introduction, focusing on GAO versus DHCP-v6 to try to clarify even more. There was already text, but due to the comments last time, which was not sufficiently clear, we added more text in order that clarify few things. This GAO is a specific solution designed for algorithmically generated addresses, nothing more. And if you use an algorithm, then this can be an alternative to Slack. Okay, is not there to replace the DHCP-v6 when DHCP-v6 should be used. Okay, so GAO is for energy bandwidth limited restrained environments. When you use algorithmically generated addresses, if you don't need this, you don't have constraints, DHCP-v6 absolutely is absolutely not a replacement. Is something to be used in a specific context /deployments. Okay. And as I said, the last revision is we added, well, a couple of terms that were missing, but especially the bit we discussed the last time, the position, which is 16, but we suggested. We left it in the old position, and the GAO type, the code point 42 is taken. So we updated for 43 suggested as usual. And that's it. So we think the document is stable. The format change is not a real format change in the sense that we didn't really use those flags. They were there, but thinking again, we don't use it, so reserve it. So we think we are ready for working group last call. Okay. Eric, you are in the queue.
Oh yeah, from last time, sorry.
Oh. Okay, any comments or questions? So, yeah, regarding the working group last call, what Shweta and I have discussed is that similar to the previous documents, we might want to have maybe some additional reviews, perhaps from the working group, or also maybe a couple of early reviews. And then maybe we can, after that, launch the working group last call. Yeah.
Excellent. Good.
Okay, thanks a lot.
Thank you.
Okay, so the next presentation is on the transmission of SHIC compressed packets over IEEE 802.15.4 networks. I'm going to present the last updates. My co-author is Anna Minaburo. And well, first of all, a quick reminder on the main goal of the document. On the left side, you can see the traditional IPv6 based protocol stack for constrained devices using 15.4 as the wireless interface. And this is possible by means of 6LoWPAN as the adaptation layer, which comprises several functions, and two of them are header compression and then fragmentation. So what we want to do in this document as the main goal is to offer an alternative technique for header compression, which would be based on using SHIC. As you may recall, SHIC is the main product of the LP1 working group, and the expectation is that it should provide a greater header compression performance because it can exploit a priori knowledge of the header field values of the packets to be transmitted. So on the status of the draft, this document was adopted a couple of years ago, and today I'm presenting revisions 08 and 09, where the main updates have been in the following areas. First, alignment with the SHIC architecture draft, which has been updated twice actually since the last IETF. For that document, it's 03 and 04 revisions. And the SHIC architecture draft has been a little bit of a moving target. And yeah, we are trying to keep synchronized and aligned with the document. And it seems like recently the concepts are rather stable, at least the ones that affect our document. And however, perhaps the things that have been changing recently are some updates in the terminology. So we've tried to keep aligned with that. And then also we have provided a SHIC straighten header format for the first time in these revisions. So this is the updated table of contents, or the div of it. And as you can see, the structure is stable, And basically, there have been some updates due to the terminology changes, but the structure itself is actually rather stable. And first of all, before going into details about the updates related with terminology, here is some background on related terms, some of them defined by the base SCHC specification and some others defined by the SCHC architecture draft. So first of all, RFC 8724, which is the base SCHC document, defines a SCHC packet, which is a packet with a compressed header, and the method for header compression is SCHC. And this could be like, for instance, taking an IPv6 packet and taking the header, compressing it by using SCHC, and then the result is a SCHC packet, which is a compressed packet, okay? So then the SCHC architecture draft is updating some terms and is adding also some new concepts. So first of all, what we used to call the SCHC compressed header is now being called a SCHC payload. And prepended to that is what is called the SCHC stratum header, which indicates how to decompress the SCHC payload, which is the next field. Recall also that stratum relates with the location of the SCHC functionality in the protocol stack. So this could be like similar to sort of a layer, but it's not exactly or necessarily a layer. It could be, for instance, several layers simultaneously. And then the third field is now called user payload. It's the payload of the original packet, and it is unaffected by the SCHC process. So currently in the SCHC architecture draft, the whole data unit comprising the three fields, the SCHC stratum header, the SCHC payload, and the user payload is being called the SCHC datagram. So regarding the updated terms, here we have a summary. So the idea is we used to use the term SCHC header. Now it's replaced by SCHC stratum header. Then compressed header is now being called SCHC payload. There was the term instance that has been now sort of renamed in the SCHC architecture by endpoint. However, there is still a concept called SCHC instance, which is currently, again, in the architecture, it's defined, the SCHC instance, as the session between SCHC endpoints that use the same set of rules and a matching set of variables. And because we were using endpoint before, to avoid possible ambiguity here with the new term of SCHC endpoint, now we have replaced endpoint by node whenever possible. And finally, there were a couple of terms that we had defined directly in our draft. You may recall the single instance networks and multiple instance networks are now called single endpoint networks and multiple endpoint networks. Recall that these are the networks where single endpoint networks is that all the nodes support only one endpoint, one SCHC entity, and multiple endpoint networks comprise nodes where some of them may support several endpoints. So we have updated also the example figures accordingly. Here there is one example showing the case for the straightforward route over and for single endpoint networks. So here the change is only in the legend. What we used to call pair of endpoints is now pair of nodes. But there are a few more updates in the figures involving multiple endpoint networks. Again, some changes in the legend. What was called endpoints is now called nodes. The old instance has been replaced by endpoints, and the instances I1 and I2 have been updated as E1 and E2, sort of endpoint 1, endpoint 2. And by the way, here we, for simplicity, we assume that the same sort of identifier for the endpoint is used at the different nodes involved in the corresponding SCHC sessions. Then, so in section 4.1, we have also updated the content. This is the section that provides the frame format for single hop communication and for multi-hop with straightforward route over. So again, we are using the recent terms, SCHC datagram, also the SHIC payload, which in this case is the SHIC compressed header of the packet, the say original packet being carried over 15.4, and the user payload is the payload of the original packet also being carried over 15.4. And we have updated the figure as well that shows the format. So the whole format would correspond to the 15.4 frame payload that would start with the SHIC dispatch. So this is not new, but the dispatch indicates that what comes next is the SHIC datagram, which comprises the three fields mentioned before, the SHIC stratum header, the SHIC payload, and the user payload. And if necessary, there's also padding. And we have also similarly updated the remaining frame formats. Here we have a couple of examples. The first one is for tunnel-based route over, and we show here the term SHIC datagram and also the SHIC stratum header, the SHIC payload, and the user payload. And we do the same with the other cases. Here we have the example for the Pro, which is the pointer-based route over frame format. And here we show the SHIC payload, the user payload, and recall that the SHIC stratum header is part of the Pro header. Here it's a little bit more separate. And okay, all that was about updating the terms used in the document. Then we have also added a SHIC stratum header format. So this basically comprises one single field, which is called SHIC instance ID, which would be an unsigned integer that identifies the session between SHIC endpoints in two or more peer nodes that use a common set of rules and a matching set of variables. And the recommended size for the SHIC instance ID would be between 1 and 8 bits. And however, recall that the transmission of the SHIC stratum header would be in compressed form. So here we also show in the figure the format for the compressed SHIC stratum header, which comprises a rule ID and, if any, a compression residue. And for the rule ID, the recommended size would be between 0 and 8 bits. Recall that there are several cases where the SHIC stratum header can be fully elided. This is in single instance or single endpoint networks, and also in some particular cases in multiple endpoint networks. And in the document, we also provide a couple of example rules for compression and decompression of the SHIC stratum header provided. Rule ID 1 is defined in a way that if the SHIC instance ID is equal to the value in the target value column of the rule, then the result is that nothing is sent as compression residue. So the compression residue is of 0 bits. And in rule ID 2, if the SHIC instance ID matches the 7 leftmost or most significant bits of the target value, which in this example is 0x00, then only the least significant bit will be sent, which is a compression residue of 1 bit. So as you can see, the SHIC stratum header in compressed form will be really short in representation, number of bits to be sent over the air. The rule ID could be maybe just 1 bit or maybe a couple of bits in many cases, and the compression residue itself will be can be like 0 bits, 1 bit in most cases. Okay, so that's all the updates in these last versions of the draft. So what about the next steps? First, we plan to continue monitoring and aligning with the SHIC architecture draft. Let's hope that, as it seems that things may be stabilizing, at least the ones that may affect our document. The second point is elaborating a bit more on the transition protocol stack. So you may recall that in this document, we also define what we call the transition protocol stack, where to make it easier to adopt SHIC for use in 6LoWPAN networks. In this case, 6LoWPAN, the traditional 6LoWPAN, would be used for header compression of IPv6 headers, whereas for upper layer protocols like, say, UDP, CoAP, we could use SHIC. So in this case, we need to provide a bit more content here, and among others, we may need to define a SHIC header format for it. Then You may recall that in Appendix A, we have a number of examples of the frame formats that we are dealing with in the draft. We need to complete those. And finally, in Appendix B, we provide some assessment on the different properties and pros and cons of the 3 modes for route over that we are defining. Yeah, so not recently, but in some of the previous versions of the draft, there were some slight updates in the different route over modes. So now it might be a good moment, as it seems that these modes are getting stable, to double check again and complete the assessment in Appendix B, and then consider whether it makes sense to continue like this with 3 modes for route over, or maybe think about some alternatives. So far, this is a topic that has been considered at least twice in this working group. And so far, the consensus has always been that as long as it's clear, there's a clear applicability statement for each one of the modes, or which are the pros and cons, that it may be good to support 3 modes. But this is something we can maybe think about once we complete the Appendix B. Okay, so this is my last slide. Is there maybe any comment, any question? Okay, so if there is no comments or questions, then we can proceed to the last presentation on the transmission of IPv6 over optical wireless communication.
Thanks, Chairman. This is Youngwan Choi from Electric Korea. I'm presenting that the IPv6 over OWC, the draft number is the 3. The status, actually, we revised that the draft twice, and this is the 3rd time. We had a lot of comments from the feedback from the IEEE 80250 members and the previous meeting in the flow and the INA comment as well. So in detail, from the IEEE 802.50 members, we totally the 5 comment as you show as shown in the slides. The first one is about the introduction. Just need to highlight this kind of scenario, just where the OWC outperform the other wireless technology in IT. And second one is the kind of terminology. Just we put the 2, and the third one is the kind some interconnectivity, the single hub and the multi-hub, like that. Some interoperate the other the wireless and the Bluetooth or the other 6.0 technologies, something like that. And the first one is additional consideration about that kind of interference or something, more explanation about that one. And the last one is the related development in IEEE there, just we put that one. And the second part is that the comment and feedback is from the flow in the previous meeting. There's 2. One is the kind of optional, because the CSG is the kind of optional with that the traditional compression head compression. And the second, the comment was the suggest possibility of the generic the SAC functionality across the other allow the technologies, the indication, the S. And the last one is the simple one, the INAA. Just they said the number is the first 3 bit is the suggest we put. Okay, that's one. So just the addition that one, just the updated is the section 1 and 2 and 4.2 and 5, 6, and 8, like that. The first one is from the IEEE, the comment number 4. Actually, we put kind of that one, the comment, just we put some more explanation in the abstract part, but just we discussed the colors, and just we are going to, in the next version, this part, some more part will be to move to the introduction. And the next change is about that the 2 comments from the IEEE, number 1 and 5. In this section, the number 1 introduction, just the one is that the some more explanation, the also related to development, some STO, the works kind of just with 3 standard work there, and the other one is kind of just put some scenario about that, regarding that the number 1. And just the next slide is about that the comment from about that terminologies that they just they want to put kind of that 2 terminology SCHC and DAD, so that just to put the definition from the reference, the rated that one. And next slide is the comment from floor in the previous meeting about that the SCHC head compression. So 1 is actually that is we had the traditional head compression, but just we also add the SCHC as well. So there are 2. Just the tradition is the mandatory, but the other, the SCHC head compression is optional. So we put kind of explanation there. And the second part is about is the 6-row capability bit. The S, the just this is can use that the other technologies. So just we put kind of the more explanation, kind of the generic or kind of the functionality. The next one is the topology, kind of the single hop and the multi-hop, but the multi-hop can consist of the other the other wireless, the technology, the 6 technology, something like that. So just we kind of put the 2, the topology, single and the multi-hop, and some more the interoperability issue there. And that's when it's improvement from the feedback from the INA consideration. Just we put just the braces between braces. Just we put that the suggested the bit numbers 47. Yes, that's all they want. And the last one, just we put kind of the other SDO the works. So some reference, related reference, and the informative reference we just put like that in the 1 by 1. And further update, actually, just I invited some the contributors, the H3, the Monan Choi, Dr. Monan Choi. He is also developing kind of some consideration for security based on the autoversity environment. So he also updated the individual, the draft number 1, like the as actually the link. So maybe 3 or more, 2 or more update, and then that draft will be stable. Maybe we can incorporate some contents from the draft in the further update. That's all the changes and my presentation. Any comment and the question?
Okay, any comments?
No.
Okay, so it seems there is no comments. So thanks a lot for the presentation.
Thank you.
Okay, so it seems that we've been faster than expected. So yeah, this was the last presentation for the session. Perhaps, yeah, Eric.
Comment for you and for your draft, and by the way, good job. You may want to review the separation between normative and informative reference. For instance, RSC 8174 is informative, it must be for normative. And the IEEE references, maybe they're not at the right place. Okay, so basically, in short, normative reference, you cannot build something implementing your draft without reading the normative. Okay, and informative is nice to know. You have no time to read, that's fine. That's basically the criteria.
Okay, thank you. So, by the way, only for the record, those of you in the physical room who haven't joined the Meet Echo session, perhaps please do so, even if at the last minute, because yeah, this will keep the blue sheets updated. And yeah, so is there any comment, any other business from anyone? Okay, so if there is no comment, no additional comment from anyone, okay, so the session ends here and hope to see you all in Madrid.